Okay, uh, this video is going to be on factoring to solve the quadratic expressions, to find the roots of the quadratic expressions. Again, there are several ways that we could find those roots. This video is we're going to use factoring. So we're going to use the concept of factoring that we've used before when we first learned how to factor. We're going to use trial and error in this one, in this factoring video. You can use other methods. You can use the AC method, or you can even look up the method of factoring called bottoms up for these type of problems. But we're going to use trial and error. So we need to find our factors of 10, our ways we can multiply to get 10, which are 10 and 1 and 5 and 2. And then the possible ways that we can multiply to get our last number, which is 2, which will be 2 and 1. Now we have to find the correct group, that correct combination that'll match up, that when we multiply the outside numbers and the inside numbers, we'll end up with 9x. So we're going to set these up. These trinomials will factor out into two binomials. So we're going to start off by setting this up by using the 10 and the 1 in order to multiply to get 10, and then we'll use 2 and 1 because it's our only choices in order to multiply to get 2. Now we have to check these to see if this is the right combination, and the way that we check these is we take the outside terms and multiply those. That gives us 10x, and then we take the inside terms and multiply those. Now what we need for that to do, we need those two terms, when we get through multiplying, we need those to add up to be our middle number. And once we get that, we'll have the right combination. And as you can see, when I multiplied and added those, I ended up getting 12x, which is not the right combination because we needed to add up to get 9x. So that didn't work. So let's try 10x, and let's swap the 2 and the 1 around. Let's place the 1 here and place the 2 over here and see if that combination will work. So 10x times 2x is 20x, and as you can see, that is already bigger than that 9x, so we know that's not going to work. But we can go ahead and through the process. 1 times x is 1x, so that'll give us 21x, which again does not work. Alright, so the 10 and 1 didn't work, so let's try the combination of 5 times 2 in our first places of the parentheses. So let's try 5x and 2x, and we still have to have a combination of 2 and 1 to work. So let's start off with the 2 first and the 1 second. So let's multiply the outside terms. 5x times 1, that's 5x. 2 times 2 for the inside terms, that's 4x. 5x plus 4x is 9x. There we go. There's our combination that works. So again, the first two numbers in the parentheses, they have to multiply to be this first term, the 10x squared. The last two numbers in the parentheses are factors of the last term of 2. And we check by multiplying the outside, multiplying the inside, and adding those together, and they should equal 9x. And they do. Now that's just factoring that expression out. We want to find the roots of what, if this was an equation, of what this would be. What would the roots be of this quadratic expression? So what we have to do to find the roots, since the roots are where our graph would cross the x-axis, then we have to set each one of these factors equal to 0, and we solve each one of them, and that's how we find our roots. We take each factor, 5x plus 2 and 2x plus 1, set them equal to 0, and solve the equations. So one of my roots would be -2/5. You do the same thing over here, solve this equation, subtract 1, subtract 1. So 2x equals -1, divide by 2, divide by 2. X equals -1/2. So my roots are -2/5, -1/2. So once you factor, you take your factors, set them equal to 0, and solve. And that's how you find your roots. Okay. Let's look at this problem here. And again, we're going to use trial and error to solve this one. So I'm going to start off with stating our factors for 12 and stating our factors for 6. So we have 12 and 1, that'll multiply to be 12. 6 and 2 will multiply to be 12. And 4 and 3 will multiply to be 12. Those are all the ways that we can multiply to get 12. So far as 6, we could have 6 and 1 and 2 and 3. Now out of all of these, we have to find the correct combination that will add up to be negative 17. We want it to multiply to be a positive, but add up to be a negative. That means that both of our signs will be negative in our binomials. So let's start off with the end this time. Let's start off with 4 and 3 to multiply to be 12. So 4x here and 3x here. And then let's start off with 2 and 3 to multiply to be 6. So let's put 2 here and let's put 3 here. Let's multiply these out and see if that combination works. So 4x times 3x is 12x. And that should be minus. Sorry about that. So 4x times 3x, negative 3 is negative 12x. And negative 2 times 3 is negative 6x. That will give us negative 18x. That was close, but we need negative 17. So that didn't work. Well, let's use that same 4x. Let's swap the negative 3 and negative 2 around. So let's place the negative 3 here, and then 3x minus 2. Let's try these out. Multiplying the outside times the outside, 4x times negative 2, that gives us negative 8x. Negative 3 times 3x, that gives us negative 9x. That checks out because that's negative 17x. So here, that's my combination. So that will be the correct factoring for this particular quadratic expression. 4x minus 3 times 3x minus 2. Now to find the roots, we would take each one of those and set them equal to 0. So after we factor, we set those equal to 0 and we solve. So here, add 3, add 3. 4x equals 3, divide by 4, divide by 4. X equals 3/4. Here we want to move the 2 first, so add the 2. Get 3x equals 2. Divide by 3, divide by 3. X equals 2/3. So my roots, 3/4 and 2/3. If I were to graph this expression, that would be where my line would cross the x-axis at 3/4 and at 2/3. Okay, so that's how you use factoring to solve or to find your roots. You factor and then you set your factors equal to 0 and solve. All right, so that is your factoring, using factoring to find the quadratic equation, find the roots of the quadratic equation. All right, good luck.